I pointed out this peculiar shape of Tenerife earlier, and these are what we call rift zones. There's extensions from a central volcanic area in which Teide sits towards the northeast, the northwest, and also towards the south. Weirdly enough, all historical eruptions were happening on the rift zone. And the map in the top right in black shows these lavas of the historical eruptions on Tenerife. There was one in 1904-05, there was one in 1798, and then there was one in 1909. So these rift zones are a strange feature that we find on many ocean islands, including Hawaii. In fact, the concept of rift zones comes from Hawaii, but as so often, the rift zones seem to be much better developed here in the Canary Islands for some reason. And these are fracture systems that allow magma to come up. Now, scientists can be very complicated, and depending on the island's evolution, there could have been multiple rift zones happening at different times. Volcanoes grow, they go extinct, and new rift zones may form, and this is what the map on the left is aiming to illustrate. So here's the rift zone viewed from Teide. This is the northeast rift zone, and it's in the Sea of Clouds, but you get the idea of this long ridge that goes on for several tens of kilometers and continues underwater as well. So here now we're looking back towards Teide from the northeast end, from the Anaga Peninsula, and in the top right, I put a little box there, the red boxes where we are viewing Teide from, looking towards the southwest of the island. So La Palma also has rift zones. The Cumbre Vieja is in fact exactly one of those rift zones that continues also underwater. So the concept is starting to get familiar if we look at several islands. And there's also discussion how many branches this rift might have. It's a scientific debate, so there's multiple opinions, of course. But I like to think that we have probably 2 new rift arms forming there, but we will see how time goes on. So La Palma, as I said, had a lot of eruptions, and these can be dangerous, particularly if the lavas reach populated areas. And the eruption frequency is only about every 50 years or so, and that of course means people forget. And that of course means, well, there was nothing happening the last 20, 30, 40 years, so why not build a house there? Why not convert this garage to whatever? And this is what happened. Geologists knew about dangers, and in 1949 a big crack opened up during the eruption, and this led to this big discussion that the island might actually collapse. Now the good news is it did not collapse during the 2021 eruption, so I think the island is actually pretty safe right now, but it's a geological fact. The islands do collapse every now and then. And so does Hawaii, for example. Ocean islands do have these large landslides, and there is evidence for large landslides from almost all of the islands. So here's a few of those landslide fans that can be seen in the submarine realm as well. And they occur infrequently on a human timescale, but they do occur. And this led to speculations that they could cause large tsunami waves. And I mentioned it before, there was a big discussion about 20 years ago when scientists looked at the evidence again. And well, what people do then is they use numerical models, computer models, and this is one such computer model that got into the media. And here it models what would happen if we have a large landslide at La Palma, and a wave would be created. And then, of course, the waves would travel across the Atlantic, and it could reach the US eastern seaboard within about 9 or 10 hours, in theory. It would be approximately 20 to 30 meters high. But there's a lot of assumptions here. One assumption is that it's going in one big splurge, and it may actually come in small trickles. That's one such thing. Then computer modelers, they want to see the extreme, and then they use the parameters that allows them to come up with the the most intense type of model. So they've been criticized, these authors have been criticized for being a little selective with the extreme parameters and things like that. So the good news or the good result from this study was that the Spanish government decided, well, we can't have this discussion, no, no, no. So they put GPS stations on that flank. And for the last 20 years, there's GPS measurements every single day. And in the last 20 years, the flank did not move a single millimeter. So there's hope. But if you ask me, can there be giant landslides and tsunami? The answer is yes, but the probability is very low in our lifetime. So tsunamis, yes, they do occur, but hopefully we will not see them. And as I said, this is not a feature unique to the Canaries. We see this also in other island groups like Hawaii, and actually the Hawaiian landslides are even better mapped than the Canary ones. Talking about rift zones, we then find that these rift zones, these arms, often give rise to these landslides. These Mercedes star structures, as they're sometimes referred to, there we have these rift zones. And if the rift zones grow and produce, then they push the material in between the rifts out. And this is likely the cause for these landslides. The most recent landslide is on the island of El Hierro, and this is the scar of the landslide. It's actually the tallest cliff in Europe with 14 or almost 1,400 meters. And you can see La Palma in the background there. So here we have evidence for a large collapse, a lateral collapse of an island that was happening only about 50,000 years ago. And there's a few more of those. Here we have another curved embayment, and this is an older landslide here, the El Jolan landslide on El Hierro. And here we have yet another one. We can even see the headscarp, the fault, beautifully exposed. You can touch the fault plane where the movement happened. This is the Las Playas landslide. And here's me, being young and foolish, trying to get a sample from the fault plane, and my PhD student watching, being scared. And we made it out safely. We got the sample as well, but spectacular geology. And being able to touch the fault plane of such a giant landslide is quite impressive. So here, the evidence from Tenerife, and there we also have this large caldera. We have the rift zones and this new volcano, as I said, Teide volcano, growing in the center of the rift zones. And this is the intersection of these rifts, and that is obviously where most magma is produced. We talked about Gran Canaria earlier, and there's also landslide evidence. The northwest of the island has this bite in the apple, as people sometimes call it, and that is also a curved landslide embayment, but it's a pretty old one. And going to Lanzarote and Fuerteventura, we still see these curved embayments. They're less pronounced because the islands are older and more deeply eroded, but they're there. And here's the Jandina Peninsula, and that was a giant landslide some 20 million years ago.